This video has examples of adding, subtracting, and multiplying polynomials. Remember, the key to adding and subtracting is that you can only add and subtract things that are like terms. You can only put x's with x's, x squareds with x squareds, constant numbers with constant numbers, y's with y's, and so on. But when multiplying, you can multiply anything you want, but it is going to change things. When you take x times x, you don't get more x's. X times x is x squared. Let's look at some problems. So in example 1, we have a couple things going on. The first thing I notice is this 3 out here. Remember, order of operations would say we have to do what's in parentheses first. But those are not like terms, so we can't, and we're going to have to deal with these parentheses a different way. One way we can get rid of this set of parentheses is by taking this 3 and distributing him through his set of parentheses. So we're going to take this 3 and multiply him with the 2x and multiply him with the negative 1. So 3 times 2x gives me 6x, and 3 times negative 1 is negative 3. Now when it comes to the second set of parentheses, it may look like there's no number here, but remember, if there's no number here, we can always put in a 1. Now if I put in a 1, it's not going to make huge changes, but it is going to be kind of change because it's not just 1, it's negative 1. So we are going to go ahead and distribute that negative 1 just like we did with the 3. Watch your signs and be careful. Negative 1 times x is negative x. But be careful here, a negative times a negative is going to make a positive 3. Once you've distributed, we've gotten rid of the need for those parentheses, and now we can look for like terms to put together. So I'm noticing here I have this as an x and I have this as an x. So we can put those together. I also have a couple constants that we could put together. So let's start with the x's. If I have 6x minus x, I have 5x's, because remember that minus x has a 1 sitting there. If it helps you, you can write it in, but you don't have to. And then as far as the constants go, I have negative 3 plus 3. Well, negative 3 plus 3 is 0, so we don't need those anymore. We don't have to write plus 0, or else we'd be doing that on every problem. Right there is your simplified version of that polynomial, just 5x. Let's try example 2. Now be careful. This is not a multiply because this is a add. Do you see the plus sign in here? So don't go foiling and distributing and being all crazy with stuff here. Remember, when there's a plus sign in here, we're just taking these guys and adding them to these guys. Now, technically, there is a number in front of those parentheses. Remember, when there's no number there, it's technically a 1. But if you think about what's going to happen, when I distribute this 1 to everybody, it's not going to change anything. So these parentheses are kind of silly at this point. We don't really need them. Same thing over here. It's a positive 1. Now, if it was negative, it would have some change. But because it's just positive 1, when we multiply everybody by positive 1, we get the same stuff. All right, let's look for some like terms. And I always like to start with my bigger exponents because then they kind of end up in that nice, polite math order. Unfortunately, this guy, this 3x squared, has no like terms. So he's just kind of going to be hanging out as part of the answer. But then I do see a couple x's we could put together. I've got 5x and negative 5x. Well, 5x minus 5x is no more x's, so we don't need those. I do have a negative 7 plus 9. Negative 7 plus 9 is positive 2. And so this would be the simplified version of that addition of polynomials. Let's try a multiply one. Now, I will admit I have picked a hard one here. This is a big multiply one. Remember, a lot of them are going to be 2 terms or a binomial times 2 terms. And so those you can use FOIL if you like FOIL, or you can use distributive property if that feels better. But remember, FOIL only works when it's a binomial times a binomial, two things times two things. And in this case, we have three things times three things. So when I say things, I'm talking about terms. So here's one term, here's a term, and here's a term. So this has three terms, and this has three terms. So the only way to really tackle this, well, not the only way. The most common way to tackle this is with distributive property. So we're going to start with the x squared. And I'm going to take x squared and distribute it through to everybody in the second set of parentheses. So we're multiplying x squared times everybody in that last set of parentheses. X squared times 2x squared is going to give me 2x to the fourth. When we're multiplying, we add those exponents. X squared times negative x is negative x to the third. And x squared times negative 1 is negative x squared. Next, it's the 5x's turn. So now I'm going to take the 5x and do the same thing. Distribute him to everybody over there. So 5x times 2x squared is going to be a positive 10x to the third. And then 5x times negative x is negative 5x squared, and 5x times negative 1 is negative 5x. Next, it's the negative 2's turn. So negative 2 is going to get distributed to everybody over there. Negative 2 times 2x squared is negative 4x squared. Negative 2 times negative x, watch your signs, a negative times a negative is a positive 2x. And a negative 2 times a negative 1 is a positive 2. So we've done the hard part of multiplying, but now we've got to go find all these like terms to put together. First off, the 2x to the fourth has no friends. There are no like terms that match him. So I'm going to just write him down there. Next, x to the third. So let's see, I've got an x to the third here, an x to the third there. I think that's it. So if I put negative 1 and 10 together, I would have 9 of the x to the thirds. As far as x squareds go, I've got an x squared there, and here, and there. So let's see what we got here. Negative 1, so this is negative 1, this would be negative 5, and this would be negative 4. So we are going to have negative 10 x squareds. As far as x's go, let's see what we got. I've got a negative 5x and a positive 2x. So that's going to give me negative 3 of those x's. And then last but not least, all by himself, is that little O2 at the end. That is the simplified version of that multiplication problem. We've put all the like terms together. See, this is x to the fourth, this is x to the third. We can't put those together. They're not like terms because they don't match. Same for all the rest of these guys. This is the correct order as far as math etiquette goes. Typically we say alphabetical order, so if you had like a variable of a, it would go first. But then since we have all x's, you would put them in descending exponential power. So this is a 4, 3, 2, 1, and a 0. If you have them in a different order, but they're all still there, it's still correct. It's just kind of considered not as polite, but it's not wrong. You're fine.